One of the questions that I would like to cover first is about why do I insist that you need to turn in your tests in PDF? Why has to be like that? Okay, the very first reason, why PDF? Now I give you a screenshot of the submission given to me on, actually, yeah, this is on October the 9th. So it was on Friday. Now, what happened here, these students, she's a very good student, by the way. These students actually send a file to me. Their deadline is 10:30. Their deadline is 10:30. So that person sent the file to me at 10:22. So I will take that file. The thing is, this one file here is picture JPG file. That's why the program, the campus didn't want to take it. Okay. Now I want it to be in PDF, but there's another reason why. Here's the thing. You see that this is 2.4 megabytes, right? This is the picture of only one page. That's the picture of only one page. Now, the same person, after I asked her, you know what, I take your submission as on time, but I would like you to change that to PDF and make it into one single file. Now, this is the file. The same content, exactly the same content, but this is approximately 1.7 megabytes, but it contains 5 pages. Now, what I'm trying to say is this. If you turn it into a PDF file, the size gets smaller, and not only just a little bit smaller. It gets approximately 80% to 85% smaller. Now, take a look. This is 2.4 for one page. If you multiply it by 5 for 5 pages, that will be 12 megabytes. Now, compared to if you already converted to PDF. You see that? Okay, now then, students say, but Thomas, can I just turn it in JPG? I can make it happen, but the thing is, whoever turn it in JPG, they're the one always late. Why? Because if it takes you 2 minutes, to submit this file, it will take you 20 minutes to submit this file. Right? And then you're the one complaining that not enough time. Right? You insist on your method, but then when it's late, you kind of like blame it on me. You want to do it your way, but you wonder why it's just like ridiculous. These students didn't listen or didn't want to listen to me. And then at the end, when they mess up badly. Okay, good thing this one student, I'm talking about the one who submitted here. Okay, good thing that she tried to turn it in early, which is the deadline was for them, it's actually 10:15. And then I said, well, it's because you didn't turn it in PDF. And then she said, oh yeah, then she always turned it in correctly, you know, but this time she thought that, you know what, I just turned in JPG and it didn't work. It's like the system just keep on spinning, Thomas, but it's not uploading. And I said, well, it's because it's JPG, okay? Turning it in other format will take a lot more time and space. That's why I want you to make it in PDF, okay? Yeah, when the fact that you get 97 megabytes, it's actually okay. You can still use your scanner. Don't worry about it. But when you set it up, you scan it as a PDF and black and white. You don't make it in color. You don't need to make it in color. In fact, it is good enough to make it in 150 pixel. 150 pixel is good enough. Now, if you want to make it 300 pixel, it's okay. In fact, one page with 150 pixel will take approximately 300 kilobytes only. So even if you make it 300 pixel, it will be like around 600 kilobytes. It's still small. It's still small. Okay. having a scanner is actually better. The result after you scan it, instead of using cam scanner, the result if you use scanner is actually much better. Okay, and of course I assume because it's because it's a real scanner, then you have the option to choose how high the density, how much details you want to be get in. Okay, now that's one. Second things, why I cannot take late submission, and I need you to submit it on Canvas. Why on Canvas? Because of audit. If they audit me, okay, once the administration, let's say the dean, I don't blame it on him, he's a very nice person, okay? But once they start the audit, you know, when somebody audit you, when our IRS auditing you, it means they are looking for mistakes. They are not there to be nice, okay? They try to look for mistakes, especially if the complaint against me is like not being fair. Right? Thomas is not fair. Now then, once they audit my Canvas, they look at my Canvas, they just look for situation where I favor one student over another student. And one of the hole where I can easily get dinged is when I allow students to submit late, and I don't have evidence that that person actually submitted just reasonably late, like 5 minutes late with 5 points penalty, you know. Okay, in that case, fine, right? But I need to have evidence for that, right? Now, what happens if somebody submitted like 5 minutes late and somebody else submitted at 50 minutes late? The person who submitted 50 minutes late will only say, well, that person also late. Okay, that person also late. This person here will not say that that person only 5 minutes late. No, they will hold the word late. But we all know that if you're 5 minutes late, that's reasonable. Like, you know what, this is the first time you submitted, you don't know the details, so fine, I close my eyes, 5 minutes late, right? Okay, now that's why, but with that argument, somebody may hit me hard and say, but Thomas, it's late, okay? Now, therefore, for less than 5 minutes late, I give 5 point penalty. Okay, so the person who insisted I need to take this 15 minutes late, I can say, okay, I give you 50 points penalty. And that could be negative points. You know, okay? That's to protect me, myself. Okay, that's to protect me, myself. Next, remember I told you about alarm? I want you to set up your alarm. Okay, the system is being designed by that the deadline, the time for deadline is not when you start uploading. But when you finish. Okay, now the thing is how fast your system uploading it is something we don't know. I mean, I have no control over that, right? You may use your smartphone, you may use an internet, you may borrow somebody else's internet, and that's totally fine. But the thing is, because that's a variable, we don't really know how fast the connection is. That's why I want you to start uploading it a lot earlier. Okay, because when the system say the deadline time for the deadline is 1 p.m., it means once if your file finish uploading at 12:59:59, it will still accept that. But once it hits 1:00:00, it will not accept that anymore. Okay, so if you have 1 byte left at 1 p.m. that is not uploaded, then your whole file will get rejected. That's how they set it up. Okay, that's how they set it up. And they have their own reason why they do that. That's why I keep on making you aware about, hey, you know what? You need to get a good signal, you know, okay? And you need to get, you need to start uploading it early. Don't wait until last minute. Don't think that, oh, Thomas is just, I'm gonna do it fast. It will be okay, it will be okay. And it turns out to be not okay, right? And then you want me to understand. While when I try to understand you, somebody else may backstab me because I try to be nice to you. Right? No, I shouldn't. No, it should not be like that. Okay? If you want me to help you, do it the way I told you. Okay? Because when somebody file a complaint, you will not step up to defend me. Right? Even if you try, nobody will listen to you because they're auditing me, they're not auditing you. Okay? I have to be responsible on my class, and that's what I'm doing. Okay, now how about you responsible on your own submission with your own computer or smartphone, with your own scanner, with your own signal? Okay, I hate to say it that way though, as if I don't care. No, the thing is like, I need you to care about that because in the end, it's all our performance all together, right? There are things that I cannot control, but you can. There are things that I cannot control and you cannot control, so we try to control it another way. Right? That's why I told you that way in advance. Okay? No, the thing is like you need to get prepared with your next test. It will be soon. So on the top of what you have done so far, on the top of that, you need to know how to go online with Zoom. At that time, instead of you looking at my paper or looking at my notes or looking at my face, I will be the one look at yours. So on that day, be prepared your student ID. You know what? Basically, whatever I show on the video, I post on YouTube for how your test will be proctored. Okay. Now I don't want to be harsh on you. Actually, for those most students who turn it in okay, and students who don't turn it in okay, some of them actually have good reason. Yeah, some of them have good reason. There are 2 students actually sent me an email a day earlier. Thomas, can I start the test a couple minutes late? So actually 1 hour late. I said, fine. It means that when you turn it in, it will be 1 hour late. You know, and I have to save that conversation in case I get audited. Okay. Now let me start with the lesson then. But I hope you remember this. Okay, and learn how to convert that to PDF if you use your smartphone to take picture to convert that to PDF. Okay. I try to save your money by not don't need to buy a scanner, right? But I still have students saying that, Thomas, I don't know how to use the cam scanner on the day of the test. I don't know how to help, you know, like last minute person like that. I'm sorry. Okay, let's go back to 2.2b. I continue from our discussion last time. I will go on with page 196. If you have your textbook, please take a look there. There are some simple stuff to work on, the leftover on this section. Okay, for example, number 62. Number 62. The question is solve fx equals to 0. Now then in number 62, they give us fx equals to if fx is equal to 12 minus x squared over 5. So basically you set that function equals to 0 and then solve it. Okay, multiply both sides by 5. Add x squared both sides and then apply square root property and simplify.
Wait, you said divide both sides by 5, right?
Multiply by both sides by 5.
Oh, okay.
Okay, so x equals to 2 square root of 3, and then x equals to negative 2 square root of 3. That's for number 62. But it's basically just solving the equation, you will see. Okay, likewise, for example, if I go on with number, let's say number 70. Number 70, this question is solve fx equals to gx. So find x such that fx equals to gx for fx equals to square root of x minus 4 and gx equals to 2 minus x. Solution. I basically need to set the fx equals to gx, substitute the function, that's square root of x minus 4 equals to 2 minus x. And then you solve it. That's square root of x equals to, I add 4 both sides and then square both sides. Okay, and then we will solve this, and then because I square both sides in one of the steps, then I need to make sure I check the solution later on. So x equals, 0 equals to 0 equals to x squared minus 13x plus 36. I get x minus 4, x minus 9. So x1 equals to 4, x2 equals to 9. And because again, every time you square both sides of equation to solve an equation, you need to check whatever solution you have and formally check that. Okay, so for x equals to 4, we plug that in, square root of 4 minus 4, is it equals to 2 minus 4? 2 minus 4, is it equals to negative 2? Oh yeah, it's true, huh? So x equals 4 is a solution. Now I still need to check the other solution though, because it is possible both of them are correct. Square root of 9 minus 4, is it equals to 2 minus 9? That's 3 minus 4, is it equals to negative 7? It's definitely not. Then you summarize, so x equals to 4. Okay, that's how we solve that. Now, but these two type of questions are type of question we have seen before. Now, the main topic that I left off last time that I need to cover is the topic about the domain of a function. The domain of a function is all real numbers whose outcome is whose outcomes are also real numbers. Okay. In other words, all x such that fx is a real number. So, for example, and a lot of them actually just quite make sense. Like for example, I do number 72. Number 72, what is the domain? Find the domain of number 72, gx equals to 1 minus 2x squared. Now notice that whatever x you plug in, the output will be a real number. Whatever x you plug in, the output will be all real numbers. And will be a real number. So the domain of this gx will be all real numbers. Now, this is actually true for all polynomials. The domain of a polynomial, including linear function, linear function is a polynomial, is all real numbers from negative infinity to infinity. Number 74, what happens if we have rational function? Number 74, sy equals to 3y over y plus 5. What's the domain? What is y such that when you plug that in, it gives you undefined? -5, is it right? So all real the domain will be all real numbers except -5. So instead of asking yourself, instead of asking what kind of number you can plug in, it may be easier to ask what kind of number you cannot plug in. Okay, now this notation means all real numbers except -5. All real numbers except y equals to -5. Now in interval notation, you may write it as -infinity up to -5, parenthesis, union -5 to infinity. Okay. If you try to graph that, then the graph will be everything except that one number. Everything except that one -5 number. Okay, so you will see that in general, the domain of a rational function if you have fraction, right, is all real numbers except the zero of the polynomial, except the zero of the denominator. Yeah, because if the denominator is equal to 0, then it becomes undefined. Okay. Let's say we see number 78. Very similar question, actually. It seems to be more complicated, but it's actually not. hx equals to 10 over x squared minus 2x. You see, this is a rational function. So how about the domain? And we will first find out x squared minus 2x equals to 0 when x equals to 1. X squared minus 2x equals to 0, factor the x. So we get x equals to 0, x equals to 2. Right? Again, so the domain will be all real numbers except those two numbers. All real numbers except 0 and 2. Okay, the word except is actually represented by this backslash. Okay, so you can plug in any x except 0 and 2. So polynomial or real numbers, rational functions or real numbers except the zeros of the denominator. Now, how about square root? For example, number 80. Fx equals to square root of x plus 6 over x plus 6. What is the domain? Now the domain will be, first, inside the square root, the radicand has to be greater or equals to 0. Okay, and the denominator, in this case, because it's just a polynomial on the denominator, then that cannot be 0. Okay, so x cannot be -6, and x has to be greater or equals to -6. If I sketch the graph, the first one say that it cannot be -6, right? Everything else is okay. That's for the first one. But at the same time, it has to be at least equals to 6. Now, then ask yourself, where do they share? Which part they have a common value? Starting from -6, not including, right, up to infinity. I think somewhere in the past, I asked this question either to your class or another class. My question was, find the domain of fx equals to the square root of x squared minus 4 over x plus 3. Now, again, that's a square root. It means the guy inside the house, the radicand, has to be strictly positive. I'm sorry, not strictly. It has to be non-negative, maybe 0. Okay, so this guy has to be at least 0. Because if it's negative, the square root will make it a complex number, imaginary, right? Okay. Now then, how to solve that? We do 3-step procedure because that's a nonlinear inequality. So critical numbers. Remember this procedure? Long time no see. I think this is section 1.8. Yeah, that's 1.8. Yeah, 1.8. Now, every time you solve nonlinear inequality, I require you to show that in 3 steps. Okay, step 1, critical number. Critical number, I'm sorry, should be equal to 0 here. And then that's x plus 2, x minus 2 over x plus 3 equals to 0. So the critical numbers are x equals to -2, x equals to 2, and x equals -3. And then the second step, you do the sign graph. -3 will make it undefined. -2 will make it 0, and 2 will also make 0. Okay, and then you do the testing point for each one of them. I wonder if you remember this. I emphasized that a lot though. Actually, at that time, I spent 1 day just for this, as I remember. When x equals to 0, you will see this is negative. Right? When x equals to 3, for example, you will see this is positive, and so on and so forth. Then from there, we see, oh, I need greater, which is positive, greater than 0, or 0. So the solution will be positive, including 0. Okay, but we do not include undefined. So the solution will be -3 to -2 bracket union bracket 2 to infinity. Okay, now, let me write it as a big warning. Every time you solve polynomial or rational inequality, you need to show the 3-step procedure. Okay, you need to show 3-step procedure. What happens if I don't write the 1, 2, 3, Thomas? What happens if you don't write this 1, 2, 3 half point off? What happens if I only show the critical number and suddenly I get this? Then there will be all points off except 1, because at least you showed me the critical numbers. Okay, what happens if I don't show anything but the answer? I cut you all the points. It must be because you're cheating. That's the only way. Okay, I did it in my scratch paper. Then why don't you copy that on your work tape, on your test? Okay. Yes, you have. That's the correct procedure, though. It's not that Thomas, you just try to make my life harder. No, I'm not. I'm not. Okay, that's the correct way to do it, and I want to make sure that you actually learn it the correct way. Okay, finding the answer only doesn't save you in future. No, you need to know how things work that way. Okay, now your suggested homework from this 2.2b will be from number 59 to number 81. 59 to number 81, just do the odd ones. On 2.3, we will start working on the graph. Okay, so we will be given the graph of the function in this section, most of them. Okay, and we need to find the domain, the range. Okay, and then how to interpret the graph, and also how to find the interval where the graph is increasing or decreasing. Those are not too hard, actually. Those are not too hard. Okay, but I am preparing you for this Thursday. Now, for this Thursday, I would like you to first read section 1.1, the one I skipped last time. Read 1.1 first. Read this first, and then read 2.4. Okay, read 1.1 first, and then 2.4. My plan is on this Thursday, I will go over 1.1 and then finish up 2.3 and then go to 2.4. Maybe with 2.5. Seems to be a lot, but each one of them are actually very closely related. Okay, please read. I believe the book is readable. At least for 1.1, it's very readable, and it's review anyway. Okay, please read it. What happens if you don't get it? Don't worry too much. Okay, first read it first. Okay, the fact that you don't get it means maybe you need to read slower or read it again. Okay, but read it first at least. Don't play too much of that what if thing. Okay, I know you want to have plan B, but at least execute plan A first. Okay, plan A is you read it. What happens if you don't get it? And read it first. Because if you say you don't get it, right? We still need to ask what part you don't get. Right, so we cannot actually have plan B until you are done with your plan A. You read it first, then we figure out what part you don't get. Okay, now when I ask you to read it, doesn't mean I will not go over it. I will go over it, but I will try to go over the material that from 1.1 that is crucial. Okay, important, even though it's easy. If it is important, I will go over it. Okay, then if you have question, let's save it. Let's save your question for a question that something you cannot understand by reading. Okay, now let's start with this section. Number 10. The question is, they give you the graph. Can you find the domain from that graph? Now, if you see this notation, it means it goes indefinitely far to the right and also indefinitely far to the left. Now, then, from the graph Thomas, how do I know what's the domain? Now, what you will see, what kind of x that give you part of the graph? See, if you choose any x here, any axis here, you will get a y, right? Okay, so from here you see, oh, the domain is all real number, because any x you plug in, whatever x value of x you plug in, you will get a value. You will get part of the graph. So the domain will be negative infinity to infinity, which we usually say all real numbers. Now in my class, this notation is considered interval notation. Okay, you can write it this way, you can write it that way. Now the thing is, how about the range, Thomas? Now look at the graph again. The range is part of the graph that has the y. Okay. If you look at this graph here, the y's actually start from 0, 0, right? I mean, I'm sorry, not 0, 0. The y start from 0 all the way up. Okay, and because this goes indefinitely far to the right and to the left, then we expect this to go to infinity also. Okay, now if that's the case, then the range will be from 0 to infinity, and we can see the vertex here. The vertex here touched the x-axis, right? So it means the range starts from 0, including 0, up to infinity. Now that's for number 10. That's for number 10. It gets harder. Let's see number 12. If you look at that graph, can you tell what's the domain?
All real except 1.
All real numbers except 1, that's correct. All real numbers except 1. You see, it skips at 1, right? When x equals to 1, there's no value. Right? When x equals to 1, there's no value. Of course, we can also write this domain as negative infinity up to 1, not including 1, union 1 to infinity, but again, not including 1. You have two different ways to write that in interval notation. Okay, this is the true interval notation. This is the true interval notation. In my class, I will call this also interval notation. Okay. Now, how about the range? Yes, huh?
Okay, I got a quick question. What happens if the dots are closed? Like
if the dot is closed, means that dot is part of the graph.
So
like the one you see here, it means it's part of the graph.
Okay.
Yeah.
So when it's open, that's when that's when we bracket it off, right? That's
when it is open means it is not part of the graph.
okay.
Okay.
Yeah.
Now going back to that number 12, can you tell me what's the range? The range for this is only this point here. What's that, by the way?
-1.
-1. How about this? The range here is
1.
1. So the range will be only these two numbers, -1 and 1. Okay. Let's do more. Let's do more. We have more graphs coming in here. Let's see this one, number 40. Number 40. What is the domain? As we expect, this looks like this. The domain will be all real numbers. Okay. And it's all real numbers. How about the range?
When it 0.
No. The range. What kind of y's you get from this graph? Greater than -4 included. That's right. So starting from -4 up to infinity, right? The range actually covers from -4. You see that that's a closed circle, right? -4 all the way to infinity. That's for number 40. We will come back to this question number 40 when we discuss increasing and decreasing. Number 42. Can you tell what's the domain? What kind of x do you get from here? This is your x goes to the left, and this is the x goes to the right. So the domain will be -infinity up to -1 inclusive, right? Up to -1, and then you continue at 1 to infinity. Then how about the range? What kind of y you get from this graph? Non-negative. I like that answer. Okay, yeah, yes, it's non-negative. But in interval notation, we'll start from 0, including 0, up to infinity. Okay, from 0 up to infinity. Now, a function is decreasing if when you go from left to right, it's always going from left to right. When you go from left to right, if then it is decreasing if it's going down. Imagine if you are walking on this curve from left to right. And then in this interval, you're going down. In this interval, you go up. Does it make sense? You always walk from left to right. You always walk from left to right. Now then, with that said, then in what interval the function is increasing? Increasing on in what interval? From x equals to 2 to infinity. That's right. From 2 to infinity. It is decreasing when it is from -infinity up to 2. Now, let's try again for number 42. 42. You do it. It is decreasing in what interval? Number 42. So you walk from left to right. When you walk from left to right, at what interval you will be walking down the street? That will be between negative infinity up to negative 1. Okay, and it will be increasing in that interval 1 to infinity. Okay, now let's use that idea. Oops. I will not include the endpoints in this case. I will not include the endpoints. Different textbook define it differently, but I think our textbook, no, our textbook does not include the endpoints. Our textbook also the same with me, not including the endpoint. Okay, so we don't include the endpoints. But I have to admit that different textbook actually define it slightly differently. But the way I define it, that it is increasing or decreasing, I always use open interval, not including the endpoints. And it has something to do with, calculus later on. Okay, it has something to do with calculus later on. What kind of things in calculus that we will see, well, I save it to your calculus teacher. Okay, but when we do increasing interval, the interval where it is increasing or decreasing or constant, okay, we will use open interval. Okay, we'll use open interval. Let's look back. Let's look back to our previous part, like here. Number 10, can you tell the interval where it is increasing? The interval where it is increasing. It is increasing starting from 2, not including 2, up to infinity. Okay, now how about number 12? It is increasing in which interval? No, it's never increasing. Okay, never decrease either. But we have constant here. It is constant in which interval? Basically from negative infinity to 1, right? It is constant here, this horizontal line, not including the endpoints though. Okay, and also here. Okay, so it's constant in negative infinity up to 1, union 1 infinity. Oh, just for fun. Can you help me with number 11? What's the domain? Number 11, the domain is negative 4 to 4 inclusive. That's right. Negative 4 to 4 inclusive. How about the range? The range will be from 0 to 4, both inclusive also. Now, how about the interval where it decreasing? decreasing in what interval? From 0 to 4. Okay, but the 0 to 4 that we are talking about, it's from here to here, this region where you're actually walking down. Okay, now I define it with walking. If you walk from left to right, some people actually say that if you put the ball there, will that fall to the right or fall to the left? If it falls to the right, then it is decreasing. If it falls to the left, then it is increasing. Now somebody defined it that way, but now I think it makes more sense if you just imagine you're walking on that path. Okay, so here it is decreasing in the interval from 0 to 4. I think so far it's reasonably easy. Okay, let's go on. Number 14. Can you answer this question? Let me give you 2 minutes. No, 1 minute is good enough. It's basically asking you, do you know how to read the graph? Okay, so number 14a, what is f negative 1? When x equals to negative 1, what is the y? When x equals to negative 1, the y will be the y will be 4, right? I think that's 4. Part B, when x equals to 2, when x equals to 2, oh, this one is hard to see, but I think it's that one, huh? When x equals to 2, f2 is 3, at least according to my observation here. No, I don't think that's 4. Yeah, I don't think that's 4. I think that's 3. I don't think that's 4. Okay, how about part C? F0. This one is easy. When x equals to 0, the y is 2. That's easy. And part D, how about F1? That's 0. Okay. Now, some terminology before I go on further. From this graph, can you tell me what's the y-intercept from this graph? The y-intercept is not 2. It's 0, 2. Okay? It's a coordinate. It is a coordinate. It is a coordinate. Okay, how about the x-intercepts? The x-intercept should be negative 2, 0, and then 1, 0. Is it okay, everybody? Okay, good. Now, one more terminology. How about the 0 of fx? The 0 of a function. Now, the 0 of the function is defined to be the value c such that fc equals to 0. Okay, that's the definition of the 0 of a function. The 0 of a function is all the x such that fx equals 0, all the c such that fc equals to 0. Okay, so in this number 14, the zeros are negative 2, 1. To be more precise, the zeros are x equals negative 2, x equals 1. Now you will see the x-intercept and the zeros are very, very closely related. I can even say that in this class, all the zeros are x-intercepts. All the zeros give us x-intercepts, but they are not the same. They are not the same. Okay, they are not the same. In fact, let me say it this way. Maybe a little more notes here. Not all zeros give x-intercepts. Well, first of all, they are not the same. Okay, but like what we see from on our number 14, the zeros give us the x-intercepts. Okay, but they are not always the same. They are not always the same. Under what situation there may be different. Zeros give x-intercept only when they are real numbers. Only when they are real numbers. We will see this again in chapter 3, actually, when we deal with polynomials. Okay, but give you some illustration. I give you some illustration. Maybe, I wonder if I can shift that. Okay, here's the illustration. Okay, let fx equals to x squared plus 1. Now, I hope you remember that the graph of this x squared plus 1 looks like this. So it doesn't have x-intercepts, right? We know the range is from 1 to infinity. No x-intercept. But this thing has zeros. When we set that equals to 0, x squared plus 1, so x squared equals to negative 1, x will be plus minus square root of negative 1, x is plus minus I, right? So x equals to I and x equals to negative I are zeros of this function, but because i's are imaginary numbers, they are not real, then it is not x-intercept. Okay, then it is not x-intercept. So you may have so many zeros, none of them becomes x-intercept. It's possible. We will get into that conversation even further. We get into that conversation even further. Now, the reason I mentioned about the zeros of a function is because then in part of this section here, they do ask that question. Let's say, for example, number 26. Number 26, find the zero. Find the zeros of fx equals to x squared minus 9x plus 14 over 4x. Find the zeros of fx equals to that. Solution. We solve equation again. We basically, when we say the zeros, means you set the fx equals to 0 and solve for x. Okay. So it's again, it's solving equation. How to solve this? We learned that before. We multiply by the LCD by 4x, and I get basically 0 equals to x squared minus 9x plus 14. Fast forward, I expect you to know how to solve it yourself. X equals to 2, x equals to 7. Okay, so I basically explaining what does the word zero means. The zeros of a functions are all those x such that when you plug that x in, the output is 0. Next topic, average rate of change. Average rate of change. It has a special name because you see this a lot later on at the beginning of your calculus. But the idea is actually quite simple. Suppose you have a function. Suppose you have a function like this, let's say. And then they want to know, let's say this is our fx. And they want to know what is the average rate of change from A to B. Okay, average rate of change from A to B. Now, average rate of change from A to B is defined to be the difference of the y's, the change of the y's. Okay, the change of the y's. So this is FB minus FA divided by the change of the x, which is B minus A. So average rate of change is equals to FB minus FA over B minus A. Just like that, just like that. Which, if you think about it, that is actually the slope of this line. That's actually the slope of that line. The slope of the line connecting the points when x equals to A to the points of the graph when x equals to B. Okay, so the average rate of change is actually equals to the slope of what we call the secant line. Okay, that's the slope of secant line. Now, our textbook use a notation that you may think this question is hard, but that notation actually means that it is related to your calculus for business later on. For example, I pick number, let's say I pick number 80. Number 80 in your textbook. Find the average rate of change for fx equals to negative x cubed plus 6x squared plus x from x1 equals to 1 to x2 equals to 6. Now, notice that I basically need to compute the following solution. I basically need to compute the average rate of change is equals to F6 minus F1 over 6 minus 1. That's what I need to compute. Okay, but before we actually do that computation, let's compute that F6 first. What will F6 equal to? Negative 6 cubed plus 6 times 6 squared plus 6. I think that's equals to 6. And then F1 equals to negative 1 cubed plus 6 times 1 squared plus 1. That's equals, huh? Wow, that's 6 also? Surprise. Happens to be the same. Happens to be the same. Yeah, happens to be the same. So the average rate of change is 0 minus 0 over 6 minus 1. That's equals to 0 over 5, which is 0. Okay, there's one topic in this section that I will not do right now because I would like you to read 1.1 first. And then on Thursday, I go back to this, the later part of this 2.3, which is even function, odd function. And then we go to 2.4. The top of the equation is 6 minus 6. That's right, thank you. It's 6 minus 6. Thank you. Thank you for it. That's a very necessary correction. Yeah, it's 6 minus 6. Thank you. Your suggested homework from here, suggested homework from this 2.3a is number 9 to number 31. And then number 39 to number 45. And then number 75 to number, actually, no, 67. From number 67 to number 81. Okay, please do this suggested homework. I know you are busy, but please do so. I need that on Wednesday though. On Thursday. I need that very, very badly on Wednesday. On Thursday. Okay. Do every other odd first, maybe. If you feel comfortable, then go ahead, move forward. Okay, but if you feel, oh, you know what, I'm kind of shaky, then do the odd also, the other odds. And then remember, I have office hour from 10 to 11 on Tuesday, Thursday. And so far, the earliest somebody asked me question is actually 10:40. You know, I would like you to actually attend my office hour, come to my office hour, and then ask questions. If you have question, if you have no question, then you don't need to. Okay. Well, anyway, that's average rate of change. Now, our textbook organized something I don't really like, but I don't think they purposely do that. Going back to 2.2. Going back to 2.2, there's one part called difference quotient. Now, I said earlier that average rate of change is actually to prepare you for your calculus, right? Okay. Now, difference quotient is even closer. Difference quotient is actually the consequence of average rate of change. Now, difference quotient of a function is usually, not always, usually defined as dq of a function f equals to f of x plus h minus fx over h. That's the definition. I do ask question about difference quotient in my test too, so get prepared with this. You may even want to put a star here. Make sure you study this. Make sure you study this. Okay, I always ask this. I always ask this. And when you go to calculus, you will see this again. Okay, now let's see how to compute difference quotient. Suppose, for example, I pick number 1 of 4 in our textbook in 2.2. Fx equals to 5x minus x squared. And they ask you to find the difference quotient f of 5 plus h minus f5 over h. Now we say this is difference quotient at 5 because they already replaced the x by 5. Okay, now let's see how to compute this. Solution. I will first compute f of 5 plus h. So replace the x by 5 plus h. Okay, replace the x by 5 plus h. So I get 5 times 5 plus h minus 5 plus h squared. Let's compute this. This is 25 plus 5h minus 25 plus 10h plus h squared. Let's simplify a bit. You see the 25 cancels, right? Okay, so I get, maybe I write it down, 25 plus 5h minus 25 minus 10h minus h squared. So I get negative 5h minus h squared. Next, how about f5? We have this, right? Now I compute this. Okay, now how about f5? You will see f5 equals to what here? F5 equals to 5 times 5 minus 5 squared. That's 25 minus 25. That's 0. Now I will put that into the difference quotient. So the difference quotient of the function at 5 equals to negative 5h minus h squared minus 0 over h. This guy gives me this. This guy gives me this. And the denominator is still h. We are not done yet though, but at least I want you to follow this first. Are you okay?
I'm kind of confused.
Which part?
The second part with the F5 part.
F5?
Yeah.
The blue one here? This guy here?
Yeah.
Yeah, I just plugged it in here. Yeah, if fx equals to 5x minus x squared, then f5 will you replace the x by 5.
Oh, okay.
Right? Okay?
Yeah.
Now,
Yeah, I get
it. That's so far this is the initial steps. The thing is we need to simplify this. Okay? Now the common question is, Thomas, when we simplify, how far we should simplify? We need to simplify as far as simplify such that if we replace h by 0, they do tell us that h cannot be 0. H cannot be 0. And we are not replacing h by 0. No, that's not what we are doing. But if you wonder how far we need to simplify, you simplify as far as if you replace h by 0, then we don't get we don't get 0 over 0. That's how you know that you can stop. Okay, like for this question here, I will go on factorizing negative h out and then cancel the h. And I get negative of 5 plus h, which is negative 5 minus h. See, notice that I didn't stop here. I didn't stop here because when I replace h by 0, I will get 0 over 0. So I don't stop there. I factor the h here, but I still don't stop here because when I replace the h by 0, I still get 0 over 0. Okay, so I go even further. Now, do not replace the h by 0, though. That's not what I'm saying. I'm not saying that you need to replace h by 0. No. You know you can stop when you replace the h by 0, you don't get 0 over 0. That's how we know we can stop at that point. Number 106. Number 106, we have fx equals to 4x squared minus 2x. And the difference quotient they want us to do is f of x plus h minus fx over h. Find the difference quotient. Solution. We already have this fx. We already have that. The one we don't have yet is this. Okay, so let's find that out first. First step, f of x plus h is equal to, replace the x by x plus h. Okay, that's what I will do. I will replace all the x by x plus h. So f of x plus h is 4 times x plus h squared minus 2 times x plus h. Now you need to be really good with your basic algebra already at this point. Okay, and please, you are at 200 level and you are going to calculus for business. So you can say this is pre-calculus for business. Okay, do not think that the problems is so easy that you can look at that and then you can just get the answer right away by just looking at that. If math is that easy, then you know the passing rate will not be that low. In fact, it's the other way around, because too many students, including you, maybe think that, oh, math is supposed to be easy. I should not be thinking too hard. Therefore, I don't need to show any work. That's what makes you fail the class. Okay, no. You have the brain. Use it. Okay? If math classes is that easy, then the passing rate for math classes it must be a lot higher. No. But math class also not that hard such that it's not doable. But you still need to do it. That's the thing, though. That's the thing. You have to do it. It's not that you can just see it. No. Okay? There's no phrase say that look at your math. No. study your math. No, it's actually do your math. You have to do it. Okay? That's actually one of the very first advice I get from the teacher who prepared me to be a teacher. Now, that teacher who trained me to be a teacher said on the first day of class, said, when you teach your students, keep reminding them that we do the math, we never read the math. Okay, we study our math by doing it, not by reading it. Okay, okay. So please do that though. Work it out. If you never work it out, then of course you don't have enough practice. Then you don't know how to do it when it comes to the test. But if you get used to it, it will become something automatic. Okay, that is x squared plus 2hx plus h squared. You know, I FOIL that, perfect square, right? Minus 2 times x plus h. I will distribute both of them at the same time. This is 4x squared plus 8hx plus 4h squared minus 2x minus 2h. Then we do the difference quotient. On the top left, we have this yellow one. Okay, on the top left, that will be 4x squared plus 8hx plus 4h squared minus 2x minus 2h. Minus the fx, which is 4x squared minus 2x all over h. Now, I hope you follow me in writing. Now then you see the 4x squared cancels, right? They subtract each other, and negative 2x also cancel. So we are left with 8hx plus 4h squared minus 2h over h. Now, if you wonder, can you stop here? Then try plugging in h equals to 0. When h equals to 0, you will get 0 on the top and 0 at the bottom. Then you know you cannot stop here. You have to go on. I will factor the h on the top. And we'll cancel with the h at the bottom. That's why I have to factor it first. Now you see the final answer here. If I replace h by 0, I don't get 0 over 0. That's how I know I can stop there. Okay. Now, like what I said, difference quotient has a lot to do with average rate of change. So after you're done with that average rate of change, then you go back to 2.2. Okay, continue on 2.2, number 103 to number 109. Okay, so make sure you continue there. Anybody here? More suggested homework below. Okay, that's for today. And make sure you read